Okay. So in the yesterday's lecture, we have discussed about various soil moisture constants. Okay. So we have discussed about what is the saturation capacity. So saturation capacity is the maximum capacity of soil for holding the water. So it is having the highest moisture content. After that, we have discussed about the second soil moisture constant, that is the field capacity. We know what is field capacity. So field capacity is the amount of moisture content which is retained in soil after draining the gravitational water. We have discussed about three classes of soil water. In that, one is a gravitational water. So when from the saturation capacity, from the maximum moisture content in a soil, when gravitational water drains out from that area, then the moisture content at this particular level is called as a field capacity. After that, we have discussed about the point wilting coefficient. So wilting coefficient is the lower end of available moisture. If the moisture content falls below the wilting coefficient, then the plant may lose its turgidity permanently. So what is essential for growth of crop for getting maximum yield? The moisture content in the soil should have in between the field capacity and wilting coefficient. Okay, so this particular difference between these two moisture content, that is field capacity and wilting coefficient, is actually called as a available moisture. Then we have discussed about the next moisture content, that is a temporary wilting point. So temporary wilting point is the amount of moisture content at which the temporary wilting of crops takes place. Crop loses their turgidity temporarily, and when sufficient water is added, then they regain its turgidity. That is a temporary wilting point. And the ultimate wilting is one more soil moisture constant. So it is the moisture contained in the soil at which the permanent wilting of crops takes place. If we add some water to the soil, then also the crops will not regain its turgidity. So this is about the ultimate wilting point. Then we have discussed about the term available moisture and readily available moisture. So what is available moisture? It is a difference between field capacity and wilting coefficient. That is called as the available moisture or available water. So this available water is actually useful for growth of crops. Okay, the moisture content below the available moisture is not useful for the crops. In that case, the yield of crop will be reduced or the crop may die by losing its turgidity. Now, what is available moisture? It is a difference between field capacity and wilting coefficient. So, available moisture is equal to field capacity minus wilting coefficient. We have discussed this table yesterday. And there is a term readily available moisture. So, readily available moisture is what? It is a portion of available moisture that is most easily extracted by the plants. And this readily available moisture is taken as 75 to 80% of available moisture. Now, for example, here in this table, for sandy soil, the field capacity is 9 and wilting coefficient is 4. And that's why available moisture is 5. So available moisture is 5 and readily available moisture is either 75 to 80% of that. So readily available moisture, if we consider 80% of available moisture, then readily available moisture value will be 4 in this case. So that is the meaning of readily available moisture. Means this amount of moisture crops can extract easily. There is no much tension over the roots of the crops if the moisture content is equal to the readily available moisture. Now, in continuation with this, we are going to discuss the next point, that is how to calculate depth of water stored in a root zone and which is available to the plant. Okay, so here we are going to learn how to calculate the available moisture depth, DW. DW is what? It is the available moisture depth. And for that, formula is gamma D into D upon gamma W into FC minus WC. Okay, now see the explanation for this particular formula. Okay, let small d be the depth of root zone in meters. Okay, there is a root zone depth of soil. So d is what? It is that depth of root zone, which is measured in meters. Then let FC be the field capacity. So we know that this field capacity is nothing but it is a soil moisture constant and it is expressed as a ratio. Then consider gamma D. All of you know that gamma D is dry unit weight of soil. And gamma W is what? It is unit weight of water. Now consider a unit area of soil. Okay, unit area of soil, let us say 1 square meter. Now, in order to calculate the field capacity or the moisture content, okay, how to calculate field capacity? The formula is weight of water retained in unit area. Weight of water retained in unit area divided by weight of soil of unit area. Unit area we have considered as a 1 square meter. So what is the weight of water retained in unit area? And what is the weight of soil in unit area? So if we have to write expression for weight of water in unit area, weight of water retained in unit area. Okay, so this is calculated as FC into gamma D into D. Okay, FC into gamma D into D. And hence the depth of water stored in root zone depth D. Okay, depth of water stored in root zone depth D is now given by the formula FC into gamma D into D upon gamma W. And this is in meters. And from that, we get the available moisture depth formula. Okay, it is a gamma D into D upon gamma W into FC minus WC. WC is wilting coefficient, FC is the field capacity. So both are the soil moisture constant values expressed as a ratio. Okay, now all of you know the term apparent specific gravity. So apparent specific gravity SG is what? It is gamma D upon gamma W. So that's why the final formula for dW is SG into D. D म्हणजे काय? It is the depth of root zone in meters into bracket FC minus WC. So this is how we can calculate the depth of water stored in root zone depth. In root zone depth small d. Okay, depth of water stored, for that notation is dW. And depth of root zone, for that notation is small d. So using this formula, we can solve the problems on calculation of either root zone depth or depth of water stored in a root zone. Okay. So yesterday also we have discussed about this classes of soil water. See the left diagram. We have discussed about the term gravitational water. We have discussed about the term capillary water and hygroscopic water. So hygroscopic water is called as the unavailable water because this water cannot be used by the plants. And capillary water is actually the available water. Out of the available water, okay, some part is a readily available water. Okay, so here it is written that readily available water to the plant. And gravitational water is the water which goes out from that area, okay, which drains out from that area. So it is also not used for its for growth of plants. So with reference to these classes of soil water, okay, we have to solve the problems. Okay, now consider this first problem. So I have given some problems in assignment. So same problems are here. So in that, the first problem is the field capacity of certain soil is 15%. Okay, so FC for certain soil is 15%. Okay, and the moisture content of the soil before irrigation is 8%. Before applying water to the soil, moisture content is measured and it is 8%. And field capacity, that is, it is the moisture content that can be used by the plant. Determine the depth up to which the soil profile will be weighted with an application of 60 mm of water. So what we have to calculate here, we have to calculate here the depth up to which the soil profile will be weighted. Means we have to find out what is the depth of root zone of the crop. And for that, the application of water dW is given as 60 mm of water. Okay. Then see the next sentence. Take the dry unit weight of soil as 15.3 kilonewton per meter. Okay. So from that we can calculate the appearance specific gravity SG with the formula gamma D upon gamma W. So gamma D is given as 15.3 and we know that gamma W is 9.8 kilonewton per meter cube. By solving this, we came to know that this apparent specific gravity is 1.50. And the formula to calculate dW, that is depth of water applied. So formula is Sg into D. What is Sg? It is gamma D upon gamma W. So Sg into D into bracket Fc minus moisture content before irrigation. Now we know that Sg is 1.56. We have worked out. dW is what? It is a application of 60 mm of water, dW, depth of watering. Then Fc is given as 0.15 and the initial moisture content before irrigation is 0.08. So according to this formula, we came to know that the depth up to which soil profile will be weighted if 60 mm water is applied to the soil, okay, who is having 8% of moisture content before irrigation, and to reach it up to field capacity of 15%, the depth of root zone weighted will be 550 mm. So I hope it is clear to you. It is very simple. There is only one formula, that is Sg into D, or formula is gamma D upon gamma W into D. Gamma D upon gamma W is Sg. So Sg into D into bracket Fc minus either wilting coefficient or moisture content before irrigation. So from this, we can calculate what is the depth of root zone, which is weighted due to the applied water, which is a 60 mm. So this is the first example. Now see the second example. The field capacity of certain soil is 20%. Okay, field capacity is 20%. So here, what is given data, it is written here, FC is 20%, which is expressed as a ratio. It is 20 upon 100. 20% means 20 upon 100, so it is 0.2. and its apparent specific gravity is 1.6. So let us note apparent specific gravity 1.6, which is gamma d upon gamma d. Now see the next sentence. Before applying irrigation water, okay, before applying irrigation water, a wet sample of soil was taken and its mass was found as 150 grams. Okay, before applying the irrigation water to find out the moisture content. Now see in the previous problem that moisture content was given as 8%. But here moisture content is not given directly. Instead of that, some values are given so that from these values, we have to find out what is the moisture content before applying irrigation. So for that, here the weight of soil sample was taken and its mass was found as 150 grams. The same sample is weighted as 136 grams after oven drying. So dry weight of soil sample is 136 grams. So weight of oven drying sample 136 grams and weight of soil sample is 150 grams. Determine the depth of water that must be applied to irrigate the soil. Okay, so what we have to find out, determine depth of water. Okay, so means what we have to calculate, we have to calculate dW. That must be applied to irrigate the soil to a depth of 0.9. So depth of root zone will be 0.9 meter. Okay, so here value of D is 0.9. So likewise, you list out the all given data. Okay, and from that, again, you think about the final formula. What is final formula? dW is equal to depth of water required to bring moisture content to field capacity is equal to Sg, that is gamma d upon gamma w, into d into bracket Fc minus moisture content before irrigation. So here, to calculate the moisture content before irrigation, so all of you have performed the experiment in geotechnical engineering, that how to calculate the moisture content of the soil. So for that we have two weights, weight of wet soil sample and oven dried sample. So from that formula is the weight of wet soil sample minus weight of oven dried sample divided by weight of oven dried sample into 100. So if we put these values 150 minus 136 upon 136 into 100, so we get the moisture content before irrigation, which is 10.29%. So when we get moisture content before the irrigation, now we have to bring this moisture content to 20%. Initially it is 10.29%. So moisture content before irrigation, if we subtract this from this field capacity, then we get the available moisture. So now by putting these values in the formula, okay, formula is dW is equal to Hg into D into bracket Fc minus Mc before irrigation, moisture content before irrigation. So Hg is given as 1.6, then depth of root zone is given as 0.9 meter, Fc is 20% and moisture content before irrigation is 10.29%. So by putting all these values, we get the depth of water required to bring the moisture content up to field capacity as 0.139 meter. So let us say approximately equal to 140 mm. So there is a simple one formula. dW is equal to Sg into D or gamma D into gamma W into D into bracket Fc minus moisture content before irrigation or wilting coefficient. Okay. Now this is the third problem, example 3.5. To find the field capacity of soil for the following data. So here some data is given. From that we have to find out what is its field capacity. So here root zone depth is given as 2 meter. The root zone depth is given as 2 meter. Existing water content. Existing म्हणजे काय? It is a moisture content before applying irrigation is 5%. Dry density of soil is given as 15 kilonewton per meter. Then see water applied to the soil, its volume is given. Volume किती दिलेला आहे? 500 meter cube. Water loss due to evaporation and deep percolation. So how much water loss takes place due to the conveyance losses, that is in terms of evaporation and deep percolation, is given as 10%. And area of the plot to which this water is applied, 500 meter cube, is given as 1000 square meter. Okay. Now see, we have to find out the field capacity. We have to find out the answer for field capacity. So how we get the field capacity? So field capacity is what? It is the existing water content before applying water to the soil plus the moisture content added to the soil. So here initial water content is 5%, and now we have to find out how much moisture content is added for given data. So that we have to calculate so that we came to know what is the field capacity for the given data. Now see here, it is given that water applied to the soil, this volume is given. So 500 meter cube volume is water applied to the soil. Okay, and it is given that the water losses due to evaporation and deep percolation. त्याला आपण काय म्हणतो? Conveyance loss. So conveyance losses are 10%. So 500 meter cube water is applied, but out of that 10% will get wasted. So 10% of 500 meter cube is how much? It is a 50 meter cube. So if we subtract these losses, 50 meter cube, from the total water applied, which is 500 meter cube, we came to know the water actually applied to the soil or water which is actually used in the soil. It is 450 meter cube. So this much volume of water is applied to the soil. Now in order to calculate the dry unit weight of soil, or in order to calculate the weight of water applied, so what we have to do? We have to multiply the volume of water actually applied, which is 450 cubic meter, with unit weight of water, which is 9.81 kilonewton per meter cube. So the weight of water applied to the soil is 4414.5 kg. So from the given data, we have worked out what is the weight of water. Now, again, in the similar way, we can find out what is the weight of the dry soil. So weight of the dry soil, how we have to calculate? The area is given, area of the plot is 1000 square meter. Then the root zone depth is 2 meters. So 1000 square meter is the area, and the depth of root zone is 2 meters. So 1000 into 2, it is 2000 meter cube. And it is multiplied with 15. What is 15? It is a dry density of soil. So it is 15 kilonewton per meter cube. So volume is 2000 meter cube and dry density of soil is 15 kilonewton per meter cube. For 1 meter cube, dry density is 15 kilonewton. So what is the weight of dry soil? It is 1000 into 2 into 15, that is equal to 30,000 kilonewton. Now from these two weights, that is weight of water applied and weight of dry soil, what we get? we get how much water is added. Okay, percentage of water. So how to calculate percentage of water added? Percentage of water added is equal to the weight of water applied upon the weight of dry soil into 100. So we get the percentage of water added as 14.72. Now, from this data, we get one value. What is that value? That value is 14.72%. 14.72% water is added to the existing moisture content, existing water content. Existing water content is how much? It is 5%. So if we add the existing water content in water added to the soil, which is 14.72%, addition of these two is what? It is a field capacity. So field capacity is equal to 0.05 plus 0.1472. That is equal to 0.9197, means 19.72%. So that is the answer for the question. Find the field capacity. It is 19.72%. So this is the answer B. So likewise, the problems are asked, but till now no such problems are asked in the exam. But you must know how it is worked out. Okay, how to work out field capacity, how to work out the depth of root zone, or how to work out the depth of water applied to the crop. So these are the problems on this particular point. Okay, after this, we are going to discuss about how to find the frequency of irrigation and how to find the area, how to find the time required to irrigate a certain area. So whatever we have discussed up till now, all the things are shown in this particular graph. So what is this graph? This graph is a graph plotted between the moisture content of the soil versus the rate of growth of crop. Okay, so see, the rate of growth of crop is very close to zero if the moisture content is less than wilting coefficient. See this particular dotted line. Okay, this particular point is what? It is a moisture content equal to wilting coefficient. If the moisture content is less than this, then crops will not grow. Okay, so if moisture content is less than wilting coefficient, then we know the term field capacity. What is field capacity? It is the moisture content in a soil after draining free water. So the difference into moisture content, that is wilting coefficient and field capacity. Okay, so these are the two values. We have solved problems now. So these are the two values. So difference between these two is called as what? It is available moisture. Okay, there is a term available moisture. Okay, up till now we have solved three problems in which the formula was field capacity minus wilting coefficient, or field capacity minus initial moisture content. So meaning is same. So difference between this is what? It is available moisture. Now there is a one more term. Okay, that is we have discussed readily available moisture. Okay, available moisture can be used by the plants, but readily available moisture can be easily used by plants. Okay, so readily available moisture, we have discussed that it is taken as 75 to 80% of the total available moisture. So if we know what is the available moisture, then 80% of that we can find out the what is the readily available moisture. So readily available moisture is having some lower limit, and that is denoted by M0. M0 is what? It is a lower limit of readily available moisture. And field capacity is what? It is higher limit of readily available moisture. Okay, and available moisture is the moisture content between field capacity to wilting coefficient. So this figure is self-explanatory, and we know that if there is a readily available moisture, then the growth of the plant is optimum. If the readily available moisture is maintained in the soil, so that there will be some optimum water content in the soil, and hence the rate of growth will be the highest. The rate of growth will be the lowest if the moisture content is less than wilting coefficient, and also the rate of growth will be lowest if moisture content is more than field capacity. If the moisture content is up to saturation capacity, then this value of rate of growth of crop reduces. So that is the impact of various soil moisture constant values over the rate of growth of crop. Okay. Now we are going to see how to calculate the frequency of irrigation. Okay, the term is frequency of irrigation. Okay, how to calculate frequency of irrigation. And formula for frequency of irrigation is the depth of water applied for each watering, which is denoted by dW, depth of water applied for each watering, divided by daily consumptive use rate of water, daily consumptive use rate. So dW upon Cu, if we calculate this, then we get the frequency of watering in day. Now the question is how to calculate depth of watering required for each water. म्हणजे समजा एक क्रॉप आहे, त्याला समजा 10 वेळा वॉटरिंग करावं लागत असेल, तर प्रत्येक वेळेला किती वॉटरिंग करावं. So same formula is there, what we have discussed before this. dW is equal to gamma D upon gamma W into D into bracket FC minus only change is MO. MO म्हणजे काय? MO is a lower limit of the readily available moisture. So if we keep this moisture content, then we get the depth of water applied for each watering as dW. And then frequency of watering we can calculate from dW upon C. Now observe this particular graph again. Okay, so this graph is plotted between time versus moisture content in soil. Okay, it is a time. This time may be a part of base period. Okay, base period means what? It is a time required from sowing to harvesting. That is a base period. Time required for first watering and last watering. That is a base period. Suppose at the first watering, now carefully observe this figure. Suppose at the first watering, the moisture content is up to field capacity. See this above line. This above line represents the field capacity. Okay. So at certain time, let us say at time 0, the moisture content is up to field capacity. Now the consumptive use of water takes place. Okay. So here consumptive use of water takes place. Crops are using this readily available moisture, and now the moisture content reduces to the value M0. What is M0? M0 is lower limit of readily available moisture. Okay, M0. So is it clear to you? FC is a field capacity. Field capacity पर्यंत moisture content आहे. नंतर त्याचा यूज सुरू झाला क्रॉप कडून आणि मग ते moisture content decrease झालं. M0 value that. So when it reaches to M0, then now there is a need to add the water. Means we have to apply the water to the crop so that moisture content again reaches to the field capacity. Again, the consumptive use of crop takes place in due course of time and moisture content reaches to M0. So again, watering is required to bring the moisture content up to field capacity. Again, consumptive use of water takes. Moisture content reaches to M0. So again, watering is required. So this is how the number of times watering is required for the crop. Okay. So again, I will share you one more link for Zoom meeting. You please join again so that we can finish this frequency of irrigation. Okay, now we'll stop here. So please join immediately.